Nice. Okay, welcome back. I guess people can still trickle in. Hope the poker talk was cool. Um, yeah, so let's get right into this. So thanks for coming to the last two workshops. If you weren't there, we talked about React, the front end mainly, and today or this hour, we're going to talk about the back end. So yeah, if you haven't done the sign-in form again, I think everyone has to do it again for the third workshop. You can go ahead and then fill that out. And also, please hop on the question stock. Again, I'm the only one here, so I might not answer any of the questions on the question doc, but you can still. Oh, the link's on it's on the slides. Am I not sharing? I am sharing. Okay, perfect. I'll send the link to the question stock too. And yeah, also there's a bunch of React guides on the questions doc, one for the first lecture and one for both the first and the second lecture. And the slides are there too. So you can feel free to pull those up if you want a little quick refresher. But this lecture is pretty distinct from those two. So, and we're going to tie all of them together in the fourth workshop. So don't worry if you're a little lost in the first two lectures. This will be different. So let's dive in. So what did we do the first 2 hours? We reviewed 3 languages. We talked about HTML, CSS, and JavaScript. And then we learned an entire front-end library. We learned React, and people base their whole careers off of React. So yeah, that's a lot to do in 2 hours. So first, pat yourselves on the back. Not an easy feat. And yeah, you should be confused. So please ask questions on the questions talk, and I'll keep an eye on it. And either other students or I can try to answer some of them. And yeah. So the recap, we have HTML. It's the organization, the content, the bare bones of web development. It's your H1s, your P tags, your divs. And then you can style them using class names, CSS. And then JavaScript is all the logic. And then React lets you structure your website by dividing it into components and coding up each of them individually. And that's front end. Now we're going to talk about some new stuff. First, we're going to talk about what actually is a front end versus a back end. And what is a client? What is a server? Then we're going to spin into writing your own API, writing actual backend code. What does that look like? And then we'll talk about databases and how we store data onto databases. Okay, the backend. So everything we've talked about so far, really all you can do with it is like make websites that are pretty static. Like you can make your personal website. Hi, I'm blank blank. I have my resume on here. I have my like, I don't know, favorite songs. You can make it, but like put a bunch of static things onto the website. But we haven't really taught you how to do anything more than that. And usually web apps require communication, like Facebook, Instagram, Twitter, all of these websites, you need to be able to see messages, posts from other people. So this is like a different concept altogether, kind of, in that it doesn't just live on one computer. In the next workshop, we're gonna go through the coding of this little primitive Facebook website. I called it Acebook. I can demo it real quick, but Acebook demo.rokuapp.com. It's this little web app I put together that supposed to be a primitive Facebook clone if it loads. But basically what it is you can log in and then you can make Facebook posts. It's not online. That's fine. We don't actually need to be online. But basically what it is you can type in your post here and then click the post button and it'll just add it to this feed that you see. Oh, it is online. Okay, so I'm gonna log in. Oh, okay. It's I'll fix it in the break between workshops 3 and 4. So don't worry. But yeah, so you can make posts and then you can see the posts. That's Facebook. Okay, so let's think about how we could like implement Facebook or Acebook or any of these websites. But there's going to be a catch. We are going to be in the ancient times. So let's say this is like the 1500s. There's no internet, and the only way to communicate, everyone's in their houses. So in this world, everyone is just stuck in their houses and they just stay in their houses all the time. And the only way you can communicate is through pigeons. So if you want to communicate with another house, you have to write your message in an envelope and then hand it to a pigeon. And then the pigeon is going to fly over to the next house and drop the envelope there. That's the only method of communication. So you have an infinite supply of envelopes and pigeons. So you can send pigeons from house to house however you want. And my challenge to you guys is implement Facebook in this time. How would you guys like basically what if like the people in these houses wanted a Facebook? How would you go about building that? I'll give you guys like a good amount of time to like just drop things in the chat.
That's fine. So just switch the then.
There's some good ideas already.
Oh, we're by the DMV.
You guys a few more seconds to suggest ideas. All of these are incredibly good ideas. Sending a pigeon to each house, that will work.
Oh, something happened.
Ooh, I like this idea of a singular house where everything's sent.
Why?
Yeah, I mean, yeah, okay. So everyone has great ideas. And actually, most of these ideas kind of boil down to the same general idea of having this central house and everything happens through the central house. And I can explain how basically you're all correct. And this is how most of your ideas work. So let's say that Alice, Bob, Carly, and Dean live in the houses. basically we assign one of the houses to be the secretary. They're like in charge of everything. And the secretary has this giant scroll, which is like the ground truth. And the secretary keeps track of all the posts that people make. So then, whenever Alice, Bob, Carly, and Dean want to see Facebook, they want to see what the posts are, they send their pigeon to the secretary and say, hey, get me all of the posts on Facebook. And the secretary looks at their ground truth, their giant scroll, and says, okay, these are the posts on Facebook. This is what I have. And now Bob has all the posts on Facebook. Similarly, Carly might want all the posts, and the secretary will send it back in a pigeon. And then maybe Bob wants to make a new post. Bob wants to post hello on Facebook. Well, then Bob sends that information in a pigeon to the secretary. And then the secretary just writes hello onto the ground truth, the source, the main location of information.
No, I don't know. Whichever choice. I already won, Daddy. Pepsi? Okay.
And then the secretary says, okay, I'm done. And then maybe Carly wants to see all the posts again. And then the secretary sends back all the posts. And this time it includes the new post. So yeah, basically, this is how things can work. Like Alice, Bob, Carly, and Dean, whenever they want to see Facebook, they just send over a pigeon and the pigeon sends back all the posts. And then whenever they want to add a post, they send that information to the secretary, and then the secretary just adds the post. And the basic idea here is that there's this central secretary that takes care of everything and has all the information. And there's a lot of discussion in the chat of what if the secretary is untrustworthy and fakes the messages. In this case, we are just very sad. It's not going to work. But for now, we are assuming that the secretary is trustworthy, which is not a good assumption in the real world. But for now, we are assuming. And yes, I guess pigeons can get lost. There's a lot of problems here. And yeah, I guess people have many fun suggestions. Decentralized, that'd be pretty cool. But yeah, this is our model. And then I'm going to introduce another thing into this analogy. We're going to introduce artists. And what are artists? Well, when you think about it, okay, let's take this new person in the house, Emily. Okay, or Alice, Carly, Bob, and Dean, when they want to see all the messages, they send the pigeon over, and then the pigeon sends them all the messages or all the posts in this envelope. But they're just staring at text, right? I guess ideally they would be looking at a nice graphical layout of all the posts. They want to see facebook.com, they want to see the actual good UI, good look of everything. So each of these people, Alice, Bob, Carly, and Dean, we're going to hire them their own private artist. So for example, Emily here, Emily has her own private artist. And right now, basically the artist paints a picture of Facebook all the time. So initially, when Emily first starts existing, the picture of Facebook is blank because there are no posts. So the artist is painting a blank picture of Facebook. But then once Emily asks the secretary for the posts, and the secretary returns in a pigeon all the posts, the artist takes that information and paints it onto the canvas. And now Emily on her like little painting sees Facebook. And then Fred comes along and Fred also wants to see Facebook. So Fred sends over a pigeon and gets his own beautifully rendered picture of Facebook. And yeah, you can like introduce many more things into this. Like you can have ads and you can have ad blockers. And yes, there's many fun things you can do with this analogy. But my main point is this analogy is exactly how how real Facebook is implemented today and how websites are implemented today. Like this analogy is pretty much the same thing as how we're going to teach websites today. And I can prove it by using pretty much the exact same analogy, but with more modern things such as computers. So let's talk about what's actually happening on Facebook or Facebook in this example. So there are many people on Facebook and you can log in from many different locations on the globe. For example, you could be logging in from the United States. Someone could log in from Russia. Someone can log in from Australia. And you're each on your own individual computers and typing in facebook.com, facebook.com. So what we actually want to call all the users is clients. You might have heard this word client, but client basically refers to the user. Yeah. And what does the user see? What do you see when you actually go onto the web page? You see your front end code. The front end code is the code that shows up in front of you. It's like your React code, your HTML, your CSS, your JavaScript. It's what the artist was painting. It's like the view of the page. The first two lectures, we talked about front end things. We talked about how you structured the web page that you see in front of you. So that's all front end. So yeah, as you remember, your React code is displayed on the page. That's all front end code. And then we're asking, how do users communicate with each other on the internet? It's not through pigeons, but it's through this thing called HTTP requests. And instead of having a secretary, we have this thing called the server. And the server is our central system. It's where all the information is stored. Yes, also HTTPS if you want secure requests. Yeah, the server is the central hub. And the code on the server is called backend code because it's behind the scenes. It's the user themselves, they can't see this code on the server. Just like if you're in your house in the ancient times and you send a pigeon to the secretary, you don't actually see what goes on in the secretary's house. All you know is your communication through the pigeons. So the server code is backend. It's behind the scenes. So whenever you hear backend, think server. So what actually is server code? What does it look like? It's basically your own API. And what that means is on the server, you're going to tell it how to respond to many different types of requests. Because all the server is it's a place where you get requests and you respond to them. The secretary just gets pigeons and sends pigeons back. That's all it does. And it needs to know how to respond to all the different types of messages that the pigeons might bring. So in this API example on the page, there are two things that the pigeon might bring. It might bring a GET request for all the messages, all the posts on Facebook, or it might bring a post request. It might bring a pigeon saying, make a new message on Facebook. So in this case, there are two different types of messages, or sorry, two different types of pigeon requests that might come through. One is a GET request for all the messages, and one is a post request for one new message. In React, in your front end code, you'll write things like get /API /all messages and post /API /new message with whatever parameters you might want to include. This is what the code will look like in your React code. So on the front end, in order to send the pigeons out to the server, you use this code. This is like send the pigeon. Think of it as sending the pigeon. And then these right here, which we'll talk about soon, are the instructions for how to respond to the pigeon. So the secretary just looks at these when they get the pigeon, and these tell the secretary how to respond back, the server. So yeah, just showing the little diagram again. I'm a client, I'm on the website right now, and I might send a GET request to the server, and the server might see that GET request, and then it will figure out what to do. So it will acquire all the messages, and then it will send them back. We use this terminology res.send to send things back. So whenever you see res.send, think of it as sending a pigeon back from the secretary to the house. And then another user might want to post a new message. They'll send over a post request with some input.
Are you ready?
And then the server will do that action.
Voila.
And then, oh, someone's unmuted.
Because
And then, so after this push request, the server will see it, and then it will do whatever the code tells it to in the case of receiving this message. In this case, it will add hello to its scroll, where it's like location of wherever it's storing all of the posts, and then it'll return. Yeah, res represents response. Oh yeah, all the lectures will be posted on YouTube, I think soonish. I'm not sure when exactly, but don't worry about that. And then the third client, yeah, res is a JavaScript object, I believe. The third client might want to get all the messages again, and then the server will retrieve all the messages and it'll send them back. This time it will include the new message that the second client's added. Does that make sense? Any questions on how client-server communication works? I'm gonna ask in the questions doc in the Zoom chat. That's a great question. Can we make the client always check if there's a new message to update the current stream? Yes, it's going to be using something called sockets. I'm not talking about that in these lectures, but it is a topic in WebLab. So you can look at our WebLab curriculum if you want to see info on that, which I will pub in the next workshop. So stay tuned. That's another thing that you could do with sockets at John. Like, that's a great point. Whenever it gets updated, could you send messages to everyone? You can, and you'd have to use something called sockets. But yeah, that's beyond the scope of this lecture series. However, it's not difficult to figure out. So you can look at the WebLab lectures for that. Yeah, so just to deep dive into these two things, rec, res. Rec These are going to be two parameters in your server code. Rec is just information about the request. So if there's any inputs in your request, like the thing that you want to post, it will be in either rec.query for get requests or rec.body. And in the skeleton that we're going to provide to you, rec.user will also have parameters of the user who's making the request. For example, like you'll know it's Alice sending over the pigeon, or you'll know it's Bob sending over the pigeon. And if you want to send back information, you can use res.send, and that's how you send pigeons back. And the info can be an object, it can be a string, it can be whatever you want. Yeah, so I'll talk about the server code more in depth right here. So what's happening is this is the process of sending over the pigeon. So this is front end code. So this is like the house, Alice's house. And you remember we talked about use effect last time. We talked about sending a get request. That is sending the pigeon over to the server. So what happens is when we put /API/all messages, it goes to our API in the server and is looking for this all messages endpoint. And in the server, we tell it that when you hit the all messages endpoint, run the stuff inside of this function. And as a quick explanation, what this function is doing is it's saying, find all of the messages, and then using the dot then syntax, because this is asynchronous, this takes time, and then send back the messages to the front end, res.send messages. So this is the act of doing all the retrieval and then sending the pigeon back. So we are in the house, we send the pigeon to the server. The server does its computation and then sends the pigeon back. Similarly, when we want to add a new message, this is a post request. We want to hit /API/new message. That's going to go into our server code, send the pigeon over, and our server will look for the /new message endpoint, and it will respond using this code inside of the new message definition. Yeah, so this is also a great question. I'll talk about .save in a bit, but the gist of what this does is it creates a new message and it saves it to the database. And one thing to keep in mind is this rec.body is the body of the post request. So it will look at the content passed in. Also, give me a sec. Yeah, so yeah, so this creates a new message. We can get the content from what we were passing in using rec.body because it's a push request. And we can get the user info using rec.user. And then we can create this message and we can save it. And so wait, what's an API again? Basically, an API is just a set of rules. It's a set of rules that we define, such as how to get all the messages or how to post a new message. It basically describes what are all the different types of messages that the pigeon can bring over. And then it tells us how to respond to each of those types of messages. So you can just think of it as like the types of envelopes that can come through. And we call each of these types an endpoint. So /API/all messages is an endpoint. /API/new message is an endpoint. And yeah, what we're gonna do is when you want to write server code, you're writing your own API for your website. So you're writing the server and you're gonna specify how your front end can make requests to your server. You're telling your own React code, these are the things that you're allowed to ask for. And then in your React code, you can make those GET requests. You can make those push requests, but you can only make the ones that you define on your server, because those are the only ones your server will know how to respond to. It's kind of like training the secretary. You're telling the secretary how to do things in your server code. Any questions so far about all of that? Definitely a lot going on there. Or are people feeling okay? Feel free to ask questions. Okay. Moving on then to databases. So what's a database? A database is where you store data. So if you think back to the earlier example, the secretary, if you remember, would store all of the posts that were made on Facebook. And the secretary would write this on their piece of paper, their scroll right here. And that's a database. That scroll represents a database. So one thing you might ask is like, why can't you just like, okay, one thing we could do is we could have the scroll be a text file, and we store all of the posts that come in a text file on the server. Any thoughts on what could possibly be wrong with that? Yeah, these are all correct. It would be hard to search. It would just be text, no room for other types of data, safety concerns. Yeah, all like it'd be hassle to parse. All correct. A text file is annoying. Yeah, like another thing is your server could just crash and then you'd lose all Facebook posts. Imagine if like imagine if everything was stored on the text file on some computer. Everything on Facebook was stored in a text file on some computer in like California. And then suddenly someone broke into Facebook headquarters, took a baseball bat, and swung through the computer. Immediately, all the data would be lost and everyone's Facebook posts would be deleted. Or they could steal it. That's a great point. They could steal it and they would be able to see everyone's private Facebook posts. That would be crazy. So fortunately, databases solve all these problems for us. And the database we're going to use is MongoDB. You might have heard of it. You might have used like Firebase, other databases, but we're going to use MongoDB. This is what the interface of MongoDB looks like. This is the MongoDB for Acebook, the example web app. I guess I didn't show it, but I will show it next workshop. And as you can see, it's kind of like the scroll. Like you have here the list of all the messages. But interestingly, it's not like a list of just text. It's a list of objects. And each object, you can see the user ID of the post, the name of the name of the user who made the post, the content of the post, hello blueprint. Then there's me, I made a post. It says hi. My friend Dan made a post. It says, what's up, everyone? It's just a giant list. And There's 68 documents in here. Yeah, it's literally just a giant piece of paper where you just can write all the messages, but it's a list of objects. And another thing to notice here is you can have multiple lists. Like we have a list for messages. We also have a list for users. And we can have more. We can have more lists in MongoDB. So it's pretty powerful. You can have a ton of different, what they're called are collections. These things are called collections. So it's a collection of messages and a collection of users. And each collection is a list of documents. So this is called a document. A document is just a JavaScript object with properties. So this document has a user ID property, the name property, the content property. All messages will have the same properties. And why MongoDB? It just is a type of database that stores a bunch of collections, and each collection is a list of documents, as we talked about, which are JavaScript objects. There's a whole nother category of databases called SQL, which you might have heard of, but we will be using MongoDB, which is not SQL. So how do you use MongoDB in your web app? John, I'm actually not sure if you must use PHP. I don't know much about SQL, but yeah. But yeah, so how do we actually use MongoDB in our code? Well, if you saw on the screen here, you have these collections, and we need to define them somewhere because clearly it knows somehow that we have messages and users. And the way to define a collection is through a schema. So the first thing we have to do is write a schema. So these are the two schemas I wrote for the Acebook app. All it is it describes what fields are in each message. So as you can see, each message has a user ID, which is a string, a name, which is a string, and content, which is a string. And then the user schema has name, which is a string, and then Google ID, which is a string. If you want to see a schema of an app that I was working on earlier, they can definitely get pretty large if you have a complicated object. This is a page for one of my web apps, but yeah, this is another schema as a real world example. Oh, that's a good question. Mongoose is the name of the thing that we use to interact with MongoDB. That's kind of what it is, but it's a thing that works well with MongoDB. It's not too important to know exactly what it is. I guess you can look it up, but that's my understanding. And yeah, there are definitely imports that you'll have to do, which I will show you guys all the how to actually use this in web apps. That will all be in workshop 4, because I'll give you a code skeleton with all of that in it. But yeah, there are imports you'll have to do. So you'll see that in workshop 4. There's a question on how you would store images or audio files. You can definitely do that in Mongo. Just rather than string, you would have to put video or image. I'm not sure the exact syntax, but there's definitely something that works there. And John asked the question, would you use this for passwords? No, probably not, because then you'd be able to view all of your users' passwords in MongoDB. But there are other ways to do it. And actually, the skeleton that we're going to provide automatically has Google login, which takes care of it automatically. But yeah, another thing you could do is just hash the password, and that would fix that problem of plain text password. So that, but yeah, that's also a thing you can do. Salting, hashing. Earl has a great question. React would show up in the inspect element part of the page because it's front end code. So any front end can show up when you inspect element. MongoDB lives on your server. It's your database. So server stuff cannot be seen through inspect element because it's on the server. It's not on your computer. Okay, so we talked about MongoDB, but how do you actually interface with MongoDB in your code? Well, let's see how we write these get and push requests. So we want to get all the messages from MongoDB. What we do is we do message.find, and we pass in an empty object. And the reason we pass in an empty object is find takes in any like search queries we want, but we don't have any search queries because we want to get all the messages. So message.find just says MongoDB, give me all the messages. And it takes time for that to happen because we have to go to the database, retrieve the message, and come back. So message.find is an asynchronous function, meaning that we have to use .then. And that's what we do. We get all the messages and then we send them back. And then when we want to add a new message, we just define a new message using the syntax. And then we do new message .save. And what .save does is it saves the new message to MongoDB. And this is .save is a function that only works on these like message objects. And the reason is because we just defined this message object in our schema. This is from the schema. So .save is not like a JavaScript thing. It's specifically a Mongoose thing that we were able to get because we defined the schema. Very convenient syntax. This will also make more sense when you see the code next workshop. And yeah, there's a lot more things you can do with MongoDB. You can find and you can pass in parameters. You can like, it's a message.find name is Akshaj. This would get all the messages from me. Message.delete one of name Akshaj content delete me would delete one message that both has my name and has the content delete me. So if there are multiple messages of that type, it will just delete one of them. And message.find one name Akshaj will just find the first message that has my name. It's not guaranteed to do it in any particular order. It'll just get some message that is from me. And yeah, a quick little summary is the backend lives on the server. So it's the secretary here in this example. And the backend acts like an API. It tells you how to do things. So as you can see the code here, it's telling us how to respond to the all messages pigeon and how to respond to the new message pigeon. This is code in the secretary. So the secretary now will be able to respond to any requests of this type. And then also the secretary can store data into the database, which is the secretary's little scroll right here. And to do that, we just have to write schemas for the types of things you want to be able to store in the database. And then we can use these handy dandy functions like message.find and new message.save. These come with the schema. And yeah, any questions on that? Yeah, Errol has it 100% correct. front end is HTML, CSS, JavaScript, and React. And the back end is the server and Mongo. What is rec.body.content? That's a great question. Oftentimes when we have get and push requests, for example, when we send a pigeon to add a new message, we also want to pass in some input, like we want to add a new message with the content hello. And in that case, rec.body.content will be the content. Like the example somewhere here. Yeah, so if you pass in this object, which has the property content, this object will be rec.body. So that I get the content, to get user input, we need to do rec.body.content. That would be the user input. Do people want to see how this looks like in the actual code base? I'll obviously do this next workshop too, but I can do a sneak peek. Okay. Sounds good. I think for context, this workshop's supposed to run until 4:40, so I got a bit more time. So I will share you guys how this looks in code. But obviously, if you have to go, feel free. Okay, give me a sec. Let me pull this up. Okay, exit full screen. Yes, I will cover this in workshop 4 as well. So, okay. So I'll recode this all in workshop 4, but if you want a little sneak peek, what it will look like is I have these like client and server folders right here. And I'm just going to show you guys the server folder because that's what we talked about. But in the server folder, we have our schemas right here. So can you guys see this? Is it big enough? Okay. So right here is the message schema. So all you do is, this is in a folder called message.js. You just import Mongoose, and then you can immediately define the message schema in this way. And then you just run this line of code. For context, no one ever memorizes things like this. You just use a skeleton that already has it. So yeah, like whenever I make web apps, I'll start from a skeleton and it will already have at least one model, and then I'll copy paste it. And like that's how I made the message. I copy pasted the user schema. So don't worry, like it's not about memorizing all these like random lines of code. It's about understanding what's going on. Yeah, there are 2 different JavaScript files because these are the 2 schemas. So this is the user schema because we're storing a list of users. And then there's also a message schema, which is for the list of message objects. There's a question, when will you give us a skeleton? Next workshop, it's in the slides. And then I can show you guys the server code. It's in this file called api.js. And there's a bunch of imports. You have to import the models. So we did that right here. Imported the user model, imported the message model. These are importing the schemas. And then there's all this random code. But this is the important stuff. This is our definition for getting all the messages. We just defined it right here. And this is our definition for responding to the new message post requests. And there's like other like push requests, like if they log in, if they log out, all this default stuff that's in the skeleton automatically. But you like, yeah, like you can think when they log in, we want to send a push request to the server. So we have to tell it how to respond to that. And when they log out, we need to tell it how to respond to that, et cetera, et cetera. But yeah, these are the important stuff. And then if you want to see the React code, yeah, we got, I guess there's a lot of stuff here, but you can see your states, you can see your use effects, you can see functions, you can see your HTML like code. And yeah, I'll go back to the backend because that's what we talked about. But any questions in the remaining 7 minutes we got? Yeah, I guess that's basically correct. Basically, get requests, get info from the server, push requests, send info to the server. Push requests can also return back information if you want them to. But on the server, these router.posts and router.get, these basically tell the server how to respond to the get requests. So these aren't actually sending any info. They're on the server and they're telling the server, how do I respond to these incoming pigeons? And like, what do I send back on the pigeon? What library is router from? I'm not actually sure. Let me scroll up. Oh, yes. I forgot to tell you guys. What you guys just learned is it's called Node.js. Node.js and Express.js. So they sound very fancy, but these are the tools that are used to power this backend. So now you know how to write Node.js and Express.js code. Congrats. So yeah, router is from Express. Can you use them on the front end? This is all backend code. So they're like instructions for the secretary. It wouldn't really make sense to do any of this on the front end because it's specifically for the backend. So yeah, Node.js is front end, is a backend language, not a front end language. You cannot use them on the front end. Any things that are particularly confusing that you want me to review at the beginning of next workshop? Thanks, John. Yeah, I can quickly talk about that. Every of these router.posts, router.gets, every of these like instructions for the secretary, they have this function in them, and the parameters are rec and res. So all rec is it's the information from the request. So it's the incoming envelope. So when the pigeon flies over, the envelope is the rec. And the pigeon that flies back from the server, that envelope is the res. So as you can see here, we can get the user information using rec.user. So the user who sent the request, we can get the body of the request, the stuff passed in using rec.body for post requests. For get requests, it will be rec.query. Does that make sense? Anything else about that I should clarify. Yeah, res sends back the information. So you'll usually only use res in the sense of doing res.send. And that's how you send the pigeon back to the house. um, I don't actually know what UDP stands for, but in the skeleton that we're going to provide to you, there is some code for sockets. Yes, I believe they're at TCP. And yeah, thanks guys. Please let me know at the beginning of the next workshop if anything's confusing and I can take some time to review anything. But stay tuned for the making of an actual web app from like zero code to finish. So yeah,